Welcome back, guys. Today we shown this question. This question is process string with special operation one. This is given a string s and consisting of lowercase English letter and special character, star and hashtag and percent character. So build name string result by process s according to the following rules from left to right. If the letter is a lowercase English letter, append it to result. If it is the star character, star sign, remove the last character from the result. And if it exists, if the hashtag duplicate the current result and append to itself. And if the percent, reverse the current result. So we just the constraint of this question is very small, so we can do the brute force solution to this. We just do what exactly the problem says. So here is the code of this question. We just do whatever this question say. We just stimulate that, and yeah, it's running in the O length, O end, N is the length of S, and yeah. So um, okay, so today we will learn some the Kubernetes on the production. So for setup the Kubernetes for the production, we need consider consider three main category, main characteristics, characteristic. We consider three main things, three main aspect. For example, the first one is availability. If we deploy the Kubernetes on a single machine, it had a single point of failure. If this server die, everything is going die. We need to create a high available cluster. What is cluster? Cluster meaning we have multi machine or multi node running at the same time. If if the if one node or one machine die, the other will running normally. Yes, and traffic will redirect to this um, this active node. We're considering so in cluster we're considering the separate control plane from the worker node. The control plane is like the way we manage the worker node. The worker node is that the exactly what application image application is running on this node. So the second thing is replicate control plane component in multiple node. That means because the control plane managed is like the um, scheduling, um, backup, recovery, and uh, redirect the request to this worker node. So that means is uh, do a lot of things. Uh, so so we just what is Kubernetes control plane does what the Kubernetes control plane does. So it have so we set uh, so is um, Yeah, it's Kubernetes API server. We have this thing here. The control plan is um, handle own start process request from the user CLI tool like kubectl. For example, we want to create a multi-pod pods it like the container is the run container runtime. That's exactly what application running on. So we can set throughout this CLI tools, we can set the auto scaling, uh, auto healing, um, and vertical scaling or horizontal scaling based on what we need through our CLI tools, and is running on the Kubernetes API server. So, and we also have in control plane, we also have the etc etcd etcd is the key value store that's um, that's storing own configuration data, and we need and the state of your resource like the CPU, the state and design state of your resource, like speed, CPU and RAM, something like this, and it store own configuration data. So if the control plane down, it that mean etcd also down, etcd also down. So we need a separate um, server running this etcd for recovery and backup the data configuration data. Yep. So is that is important part in the control plane. So we also have Kube scheduler is the is have it will watches the changing of the pod like newly create or unassign and select the optimal worker node to run it based on resource requirement and hardware constraint. The pod, okay, the pod. So is assign pod and select an optimal worker node. I think it will. The first one is if the worker down, the pod will automatically running on the active worker node, and I and this based on resource requirement that I'm thinking about if the worker node have if the worker node had different resource hardware. For example, the worker one, the worker node name one can have um, 2 vCPU and 2 GB RAM. Uh, if the and the worker node 2 have 4 vCPU and 4 GB RAM, and we need to define the pod that running on the at least uh, 3 CPU, 3 vCPU, and 3 GB RAM. And so for scheduler, we'll have the assign this pod to the worker node 2 because it because is because with is requirement is because is suit because if because if suitable for because it's suitable for because it's suitable is got is compatible with because it fit because it's matched with the requirement. Okay, I will ask Google what exactly. So control plane, control plane scheduler is automatically assign deport if requirement hardware resource based on worker worker node on hardware configuration. Yes, that's correct. The Kubernetes control plane component known as the scheduler automatically assigns pod to worker node by watching the pod's specific hardware resource requirement against the available hardware configuration and capacity of the worker node. And this is the reference. Blah blah blah. I don't know what is this. It just yeah. I think it is. Okay, drop note with inefficient CPU RAM mismatches, score ranked remain node based on resources optimization. Checking if node has enough unallocated CPU and memory to fulfill the pod container. Process requirement, template GPU. Control play. Uh, can I define the hardware resources for a pod running on the Kubernetes? Yes, you can precisely define and control the hardware resource CPU and memory for running pod on the Kubernetes. So you do is by specify request and request a limit for each container with your pod specification. Here's the quick breakdown of how it works. Request the minimum amount of CPU and memory scheduler guarantee for the container. Kubernetes use this to decide which node to place on the pod on. To place the pod on, limit the maximum amount of CPU and memory the container is allowed to use. If it is trying to exceed the memory limit, the pod will be terminated. If it exceeds the CPU limit, the container will be flooded. Okay, here we can define that here. We're running pod with the resources limit here, and we will
CP
automatically and we will and we will automatically running on the worker node that matches resource requirement. Okay, so let's back to the controller plan. We also have the control manager run various background controller like node replica and job controller. Yes, So with the, I think it's the three main things that have the highlight here. The first one is Kubernetes API server that's running that's running process requests from the user using CLI tools like kubectl and and handle that by and the and the first and the second one is etcd is the high availability and the key value store to store all configuration data. And the kubectl scheduler that's scheduling the pod running on worker node and define what is the optimized resource hardware to assign on the worker node. Okay, so what exactly control plan do? And let's back to the production cluster setup. We also yeah. So for two this for two the first one we will configuration production controller plan. First one we choose deployment tool. So basically for the high availability Kubernetes, we need to configuration the cluster. In the cluster, we have control plane and the worker node. And to do that, we can do this the by kube admin kube or short for kube adm. And for running this, we just we need uh, for the easy setup, we need one controller plane and one controller worker node. And all of that will running the container runtime. For example, the container D, and also have installation like kubectl and kube admin, and the worker node will and the admin will create the token for the worker node can use that token to join to the network that the control plane. So and then from the control plane we can uh, we can running it. For example, here I just configuration all of that on the three machine here. For example, I have three server and three server here with it's just the worker node, and my local machine is actually the control plane. And all this will need to be in the same network interface. For example, um, this three machine here will have the VBox nest here, VBox nest interface, and here I will show you uh, uh, where it does. VBox nest, VBox nest. Yes, here. It's VBox nest 0, and yes, and it have the IP on the same range of subnet here. I can check here. For example, the on the server 2 we have 192.168 and 56 and 103 on it is the same subnet with my local machine running on the VBoxNet um, network interface. Okay, so when all of us can communicate on the same network, we need to uh, create on the control plane. We need to define uh, the network that the cluster running, define the subnet network that the cluster running, and we also need the network overlay plugin and the Kubernetes to run. So I don't remember too much about the detail how to set up this because I'm using AI to do that. I just know some basics that worker can join to the control plane server throughout the token and how the control plane can manage and request to and schedule the user request throughout the worker node. For example, here I just running I just running the I need ChatGPT to know the uh, view for resources running on. Yes, let's
Gạch
define.
nối,
Yeah, as you can see that we have the control plane is my local machine and server 1 to 3 is my worker node and it's also running on the same container the um, container runtime and you can see that it have its own cluster IP address here. This is the worker cluster IP address. Okay, so we can see what is the pod that I running on, and you can see that I running the Engine X application on each worker node. Okay, so I think today is that's it. So uh, thank you for listening. Bye bye. Because my computer is too too weak too weak for running both clustered Kubernetes and streaming application OBS Studio on the same time because it will crash and run out memory. So